Hello guys, it's your favorite teacher, Godson, and you know what it is. This is Wits Lounge, Learning Made Easy. We have been studying redox reaction in the last two videos, and today we're going to be studying something new. But before that, if you say you never subscribe my video, that is to say, if you haven't subscribed yet, it is important that you do so. Please do that, subscribe and like our videos. Today we're going to be studying something new, and that is reducing and oxidizing agents. Normally in Africa, we believe in agents of darkness and agents of light. I don't know about you guys in the States and the other parts of the world, but yes, for Africa, we believe in agents of darkness and agents of light, and this is going to help us understand reducing agents and oxidizing agents. So we have already understood the principle of oxidation and reduction in the past video, and we said that oxidation is the loss of electron, which leads to an increase in oxidation number, while reduction is the gain of electrons, which lead to a decrease in oxidation number. However, when you are describing their agents, it's actually described in a different context. Before we get to that, note this, that if oxidation is one thing, reduction has to be the other, the exact opposite. So that same way, if a reducing agent has a particular properties, the properties of the oxidizing agent has to be exactly the opposite. As I said, I'm going to be using this analogy to help us understand this. And what analogy is that? Imagine, for instance, let's start with the reducing agent. So imagine you are dealing with an agent of darkness. The Africans here will know what I'm saying. Now, when you're talking about an agent of darkness only has one thing to give: darkness to the other people. So it means that if I am an agent of darkness, I would induce darkness to every other thing. What does this mean? If I am a reducing agent, I would cause reduction not to myself, but to the other reactant. So have this in mind. The first property of a reducing agent is that it induces reduction. It induces reduction to the other reactant. So once we are dealing with the reducing agent and oxidizing agent, just have this in mind, that the first property is that it will cause reduction. For instance, a housing agent would sell houses to other people. Are you getting what I'm saying? So basically that's how it works. The reducing agent has to give reduction to the other reactant. Now, back to my analogy. Imagine I am an agent of darkness, for instance, not necessarily, but for instance, I'm talking about an agent of darkness. Now, an agent of darkness can only be affected by the opposite, which is light. That same way, a reducing agent can only be affected by the opposite process, which is oxidation. Now, what does this mean? Now, if the reducing agent induces reduction, to the other reactant, itself would actually be oxidized. If the reducing agent causes reduction to the other reactant, itself would be oxidized. So the second property of a reducing agent is that it is oxidized. It is oxidized. Now, having mentioned this, when you say that a reducing agent is oxidized, what does it mean? We know that oxidation is the loss of electrons. So what does this mean? The third property is that it loses electrons. It loses electrons. Are we seeing the sequence of how this goes? Such that once you want to identify a reducing agent in a particular reaction, you first consider the fact that it will cause reduction to the other reactant. The second thing you're considering is that it is the oxidized substance. The reducing agent is what is going to be oxidized. Remember, I told you, agent of darkness will cause darkness, but it is only affected by light. Yeah, you get what I'm saying. So let's continue. Now, if it is oxidized, being the reducing agent, it implies that it loses electron because oxidation is the loss of electron. And then finally, I just mentioned earlier on in the video that once electron is lost, something happens. Once an electron is lost, you find out that what happens? That oxidation number tends to increase. So have this in mind, that once you have a loss of electron, the reducing agent would have an increase. So increase in oxidation number. So with that said, if you are looking out or looking at identifying the properties or identifying a reducing agent, the first thing you need to look out for is what is that agent that causes reduction to the other reactant. Secondly is which of them is oxidized. If you don't find it by looking at what is oxidized, you now think about the loss of electron, because oxidation or the reducing agent means that it lost electrons. And then finally, there is an increase in oxidation number. However, among these four properties, the most important property that must be taken note of is the fourth one, increase in oxidation number. So once you are dealing with a reducing agent, the oxidation number of a reducing agent must be increased. Okay, so with that said, we are done with understanding the concept of reducing agents and have to go to the next one, oxidation agents. Sorry, yeah, oxidizing agent, I meant to say. Okay, let's take this out. Let's take this out and put it down. Okay, so the question comes again. Now, remember I said something. I would like to make you understand this. We earlier said that the properties of oxidizing agents have to be the opposite of the reducing agent. So, if I tell you that a reducing agent causes reduction, the oxidizing agent has to cause the opposite, which is oxidation. So, you can give me the properties. Try writing down the properties on your own as we come to the board to then understand them. Okay, so oxidizing agent. Okay, so the first property of an oxidizing agent, as I said, is that they are agents of oxidation, so they give oxidation. So that means they induce oxidation to other reactants. That's the first property. They would cause oxidation to other reactants. The second property of an oxidizing agent is if it induces oxidation, itself has to be affected by the opposite process. I told you earlier on that agents of darkness will cause darkness, but they can only be affected by light. So you know what they said? Yeah, Bible people. Light shines in darkness, and darkness comprehends it not. So you get the point. So oxidizing agents will induce oxidation, but itself has to be affected by reduction. So it means that they are reduced. So when you are looking out for an oxidizing agent, you are looking out for the particular agent or reactant that is reduced. It's more like a paradox. The oxidizing agent is reduced while the reducing agent is oxidized. Okay, now I wrote they reduced. They are reduced. Okay, so with that said, reduction is the gain of electrons. So that means that every oxidizing agent being reduced has to gain electrons. So they gain electrons. And then finally, I mentioned earlier on that once you gain electrons, your oxidation number decreases. Look at our other videos to understand this more. I said this before, that once you gain electrons, your oxidation number decreases. So that means decrease in oxidation number. So with these properties, you would be able to identify a reducing agent and an oxidizing agent. Let's take it again. For oxidizing agents, number one is that they induce oxidation to the other reactant. Number two is that they are reduced. Number three is that they gain electrons. And number four is that there is a decrease in their oxidation number. Now, we're going to be taking an example to help us identify this or help us understand this the more. We'll start with this one. So let's put this down. Let's put this down. So I'll be putting down an ionic redox reaction. Remember, a redox reaction is a reaction which involves transfer of electrons. So once you have a reaction, and in that reaction, electrons are transferred, the implication is that that is a redox reaction. But this one on the board is going to be an ionic redox reaction. So putting that down, you have Mn2 plus Cr2O72 minus reacting to give MnO4 minus plus Cr3 plus. The question is identify the oxidizing and reducing agent. That's the question. Identify the oxidizing and reducing agent. This is quite simple. Now, we are going to be looking at the properties of oxidizing agents and reducing agents. However, I told you that the most prevalent property that is used to identify this thing now is with respect to their oxidation number and increase or decrease of their oxidation number. So if you're looking for an oxidizing agent, look at your note. You have the note, or you go back and check the video. But if you are noting things down, the property of an oxidizing agent is that it has to be reduced. And if it is reduced, there is a decrease in oxidation number. The property of a reducing agent is that it has to be oxidized, and if it is oxidized, there's an increase in oxidation number. So any of these two reactants which has an increase in oxidation number of any of its elements is referred to as the reducing agent. But if it has a decrease in oxidation number, it is referred to as the oxidizing agent. So let's check that out. Now, Mn2 plus. In our other videos, we have discussed how to find oxidation number, so please go back and look at that. I wouldn't want to spend time doing it here, so look at the other videos and you'll get to understand that. So manganese 2 plus. The oxidation number of manganese in this case is +2. Why? The rule states that the oxidation number of a charged particle is equivalent to its charge. When you come here, the calculations involved after solving, you have that this is +6. This is heptaoxo dichromate 6. Then you come here, this is +7. This is tetraoxo manganate 7 ion. And then finally here we have +3. As I said, please look up our former videos on determining oxidation number for you to fully understand why I have these numbers. That would help you a lot. So look it up if you haven't watched it. Now, with that said, we move ahead. Haven't mentioned this. If, for instance, we look at manganese here, it's +2. We go to the other side. We notice that it is now 7. So may I ask, is this an increase or a decrease? Obviously, it's an increase. 2 to 7, you were 2 years old, now you're 7. I guess that has to be an increase. So have this in mind. From 2 to 7 is an increase, and if you have an increase in oxidation number, this process from 2 to 7, what happened from manganese 2 to manganese 7 is referred to as oxidation. But what is the agent here? Remember that the reducing agent is oxidized. Therefore, it has an increase in oxidation number. Which one of these guys has an increase in oxidation number? Manganese 2 plus, because it used to be 2 and now it is 7. So who is the reducing agent? The reducing agent is this guy. So any of the reactant that has an increase in oxidation number from this side to the other side is referred to as the reducing agent. Then the one that has a decrease in oxidation number from this side to this side is referred to as the oxidizing agent. So let's check it out. Chromium here is 6, on the other side is 3. The implication is that it decreased. Decrease in oxidation number is referred to as reduction, and the agent that is involved in reduction is oxidizing agent. So it's more or less a paradox. The oxidizing agent is involved in reduction while the reducing agent is involved in oxidation. Okay, so I guess with this video you have learned something about identifying the reducing agent and the oxidizing agent. For a practice, I'd like you to do this one. To solve this one, identify the oxidizing and reducing agents in this ionic reaction. So you would have C2O4 2 minus this oxalic ion plus Cr2O7 2 minus, reacting to give CO2 plus Cr3 plus. Okay, so solve this and then find out the oxidizing agent and the reducing agent. Your answer, this eventually when you finish solving, you would have that this is the reducing agent and that is the oxidizing agent, but then solve it and then find the process. If you have any problem with this, just ask the questions in our comment section. Remember, don't forget to subscribe to our video. This is Wits Lounge, learning made easy. Thank you very much.